In this video, I'm going to find the equations of the tangent lines to this curve that are parallel to this line. So the first thing to remember is that the slope of the tangent line is going to be given by the derivative of this function. Now, I want the slope of the tangent line to be parallel to this line. What that tells me is that I want the slope of the tangent line to be 2. So to distinguish between the two functions we have here, let's call this first one f of x. So I'm going to call that one f of x. That's 1/3 x cubed minus 1/2 x squared. And so f prime of x is equal to, so I can just use the power rule. So 3 times 1/3 is 1. And I get x to the 3 minus 1, which is x squared. And for the second part of it, I get minus 1/2 times 2, which is 1. And I get x to the 2 minus 1, which is x. So that's my derivative. I want the slope of the tangent line to be 2. And I know that the slope of the tangent line is given by this derivative. So I want x squared minus x to equal 2. Now I can solve that. I have x squared minus x minus 2 is 0, which factors nicely as x minus 2, x plus 1 equals 0. And I know that's going to be equal to 0 when x is 2 and when x is minus 1. So those are the x values for the points where the slope of the tangent line is 2. Next, let's grab the y values because I'm asked to actually find equations of the tangent lines. I know that the slope is 2, but I need points. So let's see. So when x is 2, that tells me that, and remember, I'm looking for equations of the tangent lines to this curve, okay? And I know that the x values for those tangent lines are given here. To get the y values, I plug those x values back into this function. So when x is 2, y is equal to 1/3 times 2 cubed, which is 8, minus 1/2 times 2 squared, which is 4. And that is 8/3 minus 2, which is equal to 2/3. So that's my first point. Point 1, 2/3. Now for the second point, I have x is minus 1. And when x is minus 1, again, I'm going back to this function. When x is minus 1, y is equal to 1/3 times minus 1 cubed, which is minus 1, minus 1/2 times 1 minus 1 squared, which is 1. So I have minus 1/3 minus 1/2, which is minus 5/6. So that tells me that point 2 is minus 1 minus 5/6. So now I've got 2 points. Now remember that I was looking for equations of the tangent lines to the curve that were parallel to this line, which meant that the slope is equal to 2. So the slope is 2, and these are the 2 points, so I can now get the equations of the tangent lines. So for line 1, again, the slope is 2, the point is 2/3, so I get y minus 2/3 is 2 times x minus 2. I'm going to rewrite that. So y is 2x minus 4 plus 2/3. So for this line, y is 2x minus 10/3. Now for line 2, again, m is 2, and in this case, my point is minus 1 minus 5, 6. So my equation is y minus 5, 6, which is y plus 5, 6, is 2 times x minus 1. So 2 times x plus 1, which is 2x plus 2. So for the second equation, y is equal to 2x plus 2 minus 5, 6, which is 2x plus 7 sixths. So those are the equations for the tangent lines to the curve that have slope equal to 2.